Today we are going to learn about Boolean algebra. Boolean algebra means it's very useful in computer applications. Okay, so what does Boolean algebra means? Okay, before we go into Boolean algebra, what does computer do? Computer can understand only two things, as you know, 0 and 1. 0 and 1. Okay, computer can understand only this. So in normal times we can also call it as 0 is supply is on, off, 1 means supply is on, like that. Okay, or we can also say that 0 volts, some 5 volts. Like one more way to represent this is 0 as false, 1 as true. Okay, Boolean algebra is nothing but operates on these zeros and ones of different variables. Okay, now comes to the point, what is true. See, for example, take the what is Boolean algebra. Boolean algebra is nothing but logical operators and, or, not, like that. Okay, it operates on the symbols and, or, not. Okay, for example, take a switching circuit. To understand more precisely, take some statements actually. For example, Ram is intelligent. Okay, and Ram does maths well. Okay, Ram does maths well. What does it mean? And operation. Ram is intelligent, and that means this is true. Okay, I assume. And Ram does maths well. This is also true. Okay, that means and operations, when both are true, the statement will be the true. Okay, in our operations, what? For example, I'll eat idli, or for example, Ram, okay, eat idli or dosa. That means either he can choose idli or dosa. There are two options available. So only one of them is true, then it will be the true option. Okay, so we can see this in the switching circuit also. Come to the switching circuit. For example, power supply. Okay, there is a switch, another switch. This is lamp. Okay, switch A, switch B. Okay, so actually this circuit represents, this is lamp. Okay, so this circuit represents and operation. I'll explain how does it mean. For example, take A, B, and A and B is represented as A dot B. Okay, and operation. So how does it represent? For example, open means 0. If you take open means 0. This is open means this is 0. So when both are this open, this lamp won't glow. So this is 0. Again, take this. If switch A is closed, that means assume this is 1. 1 means close. Okay. Even if this is closed, this is open, the current won't flow like this. Okay, this is open, so lamp won't glow. So if B doesn't, okay, again A and B, lamp won't glow. Again, A is open and B is closed. Even that A is open and B is closed, circuit won't close, the current won't flow. Okay, now both are 1 1. That means both are closed. This closed and this closed, then only circuit flows and the lamp glows. That means 1. So this is AND operation. So this is also called truth table. This is also called truth table for for AND operation. Okay, you understood this one. Similarly, OR operation we will see. That means when both the inputs are both the variables of variables, these are called variables or literals. A and B are called variables or literals. Variables are literals. That means when both are 1, then only circuit closes, the output will become the 1. So AND operation also represented with dot. A and B is nothing but A dot B. Okay, this is not multiplication, it is A and B. This is represented with dot. Okay, this is the truth table of AND operation. So when both are 0 0, output will be 0. So in AND operation, when the both statements are true, then only the output will be the true. Okay, you remember that when both statement A and statement B both are true, then only the output will be the true. Okay, now come to the OR operation. Now take the switch circuit. Supply, lamp. Okay, this is A, this is B. Okay, now OR operation is represented by with the plus symbol. Okay, plus is not here, you have to remember. OR operation. Here you have to remember OR operation is represented by symbol plus. So A, B, A plus B. A plus B is nothing but A or B operation. Okay, so this plus is not the arithmetic plus. Okay, you have to remember that arithmetic plus is different and OR operation plus is different. Okay, now we'll draw the truth table. See what will happen if A is 0, B is 0. That means both 0 means open, both A and B are open. What does it happen? There won't be any circuit closing. See, this is open means there is no connection between supply and lamp. So what will happen? So the output will also be the 0. Lamp won't glow. 0 0. Output will be the 0. Okay, you understand this one. Next, coming to the point, when A is closed, what will happen? B is open. The current will flow. When A is closed, the current will flow in this direction. Starts from here, it goes like this, it will go to the lamp. Okay, you understand that. So that means the lamp will glow. So when A is 1 and B is 0, still what will happen? Lamp will glow. That means 1. Now A is 0, A is open, B is closed. What will happen? So the current will flow through the B because B is closed and lamp will glow. Okay, 0 1, still lamp glows. Now see the condition. When both are closed, that means current will flow through both the switches and the lamp will glow. Okay, this is the truth table for OR operation. This is very important, you have to remember. See, in OR statement, OR what we call is that even if the one statement is true, then the output will be the true. Okay, so what does it mean? In OR operation, in order to output will become true, at least one of the statement must be true, because if there are two statements, if either one of them is true or both of them is true, the output will be the true. Okay, the same thing you have to remember. And you have to distinguish between OR operation is represented by plus symbol and operation is symbol represented by dot symbol, and these are not mathematical. You have to remember that also. Okay, next important operator is NOT operation. NOT is nothing but inversion or negation. NOT is nothing but inversion or negation. Okay, in Boolean algebra, any variable, because any variable, take any variable A, B. Okay, these are also called literals. Okay, independent individual variables. Okay, in Boolean algebra we know that any variable can take either 0 or 1. So A, if you take any variable A, either 0 or 1. Similarly b, either 0 or 1. So it can take any one of the value. Okay. Now what is the not operation? Not operation is represented by, if this is a, not operation is represented by a bar. Okay. What does it mean? It's just not means inversion. It's the changing of position. For example, not operation, how does it show? For example, if a is 0, what does it? A negation or a not operation? This is opposite of that one, that is 1. Okay. For example, if a is equal to 1, what is the inversion of this one? 0. So not operation is nothing but just complementing the literal variable value. Okay. If it is 0, it becomes 1. If it is 1, it is 0. Okay. So we have learned 3 important operations. What is that? AND operation, or not operates on single operation. Okay. And means a dot b, or means a plus b. Not operation means a bar. Okay. This is the basic operations of Boolean algebra. A and b, a plus b, and a bar. Okay. There are some theorems in order to simplify the Boolean algebra. Okay. We'll learn one by one. Using either we can prove it by truth table, or we can also prove it by the different methods are there actually, duality principles, identity. We'll learn one by one. Okay. Now just now we have learned about AND operation, OR operation, and NOT operation. Okay. AND operation, OR operation, and NOT operation. Okay, we just learned these 3 things. Okay, with 2 variables. We just have taken only 2 variables, a, b. For example, if there are 3 variables, we'll also develop truth table. How to develop truth table? For example, take another variable, third variable, 3 variables. And if you require output operation like that, output a OR operation, a OR operation with b and c AND operation. Okay. If you want to develop this one, truth table. Okay. Now first what we have to do, we have to develop the maximum number of possible combinations. Okay. So what do we have to do? For example, if there are one variable, only a, how many values we get? 2 power 1. Okay, that means 0, 1. Okay. If there are 2 variables, a, b, 2 literals are 2 variables, how many Boolean combinations we get? 2 square. That means 0, 0, 0, 0, 1, 1, 0, 1, 1. Okay. Here how many variables we have? 3 variables. 3 variables means a, b, c. How many different combinations we will get? We'll get around 2 cube. That means 8. Okay. I'll write this one. If there are n variables, how many different combinations we'll get in the truth table? 2 power n. Okay, you have to remember this one. Here I will develop the truth table for here 3 variables. So it contains combination of 2 cube, 8 combinations, 8 different combinations of the variables. Okay. Take a, b, c. Okay. Now what are the 3 variables means 8 combinations? See, 0, 0, 1, 0, 0, second combination is 0, 0, 1, 0, 1, 0, 0, 1, 1. So now again this becomes 1 and same repeats. Okay. 1, 0, 0, 1, 0, 1, 1, 0, 1, 1. Okay. How many? 8 numbers. Okay. 2 cube combinations. Okay. Now what do we have to do? So we have to find a plus means OR operation, b and c. Okay. First, what will you do? We'll evaluate this one, b dot c. That means b and c. Okay, take b and c. So this is AND operation. In AND operation, what we have to do? Both the inputs has to be true, and means both has to be 1 to become the output 1. Okay, see here both are 0. So b and c means 0. Here this is only c is 1. It's not true. Again 0. Because both has to be 1 1. b has to be 1 and c has to be 1 in order to the output become 1. See here 1 0. B is 1 0, again 0. Here both are 1. Okay, here both are 1 means B and C operation will give the result 1. Same, it repeats like that. 0 0 0 1. Okay, now what do we have to do? A or B and C. We have to calculate. See here B and C we have calculated, where we know the value of A. See now what is the operation here? OR operation. OR operation. In OR operation, what does OR operation means? Either if one of the input is true, then the output will be the true. Either both are to be true, or at least one of them will be true, then the output will be the true. See here 0 0, both are zeros, then output will be 0. Here now A is 0, B dot C is 0, again 0. A is 0, OR operation. This is just OR operation. If at least one of them is true, then the output will be true. Here A is 0, B dot C is 1. So at least one of them has to be true for OR operation. So output is 1. Again 1, see 1 0, again 1. 1 0 means at least one of them is to be 1. 1 0, 1 0, 1 1. So all are true. Okay, now you understand this is the variable of three variable combination. So this A plus B dot C will become true at 5 different combinations. Okay, this is 3 variable operations. Like that we can also go for n variables. Okay, for n variables we'll get in truth table 2 power n tens. Here we are getting 2 cube, that means 8 different combinations. For if it is n variable, then we will get 2 power n different combinations. For each combination we have to evaluate the truth table. Okay.